haloalkanes and haloarenes. So this topic we shall start. So in this topic we are going to discuss the initially classification, preparation and properties. So first of all let us see what does it mean by haloalkanes. Later we shall see the haloarenes. So here haloalkanes, these are the derivatives of alkanes, alkenes and alkynes. Let us see how these are going to be formed. Initially, let us take one normal alkane. So when this alkane molecule is subjected with the halogen, one of this halogen will replace the hydrogen and finally gives the alkyl halide, which is a general name, but actual IUPAC name is haloalkane. Okay. So like this we are going to get the haloalkanes. Okay, let us try to replace this one of this hydrogen with the halogen. We get this molecule, and if one more hydrogen is replaced, we get this molecule, and we replace one more hydrogen with the halogen and we get this molecule, and finally if we replace one more hydrogen with the halogen, we get this particular molecule. So within these molecules, here only one halogen atom is there in this alkane molecule, so it is called as the monohalogen molecule or monohalogen derivative, and here two halogen atoms are there, so that it is called the dihalogen derivative. Here three halogen atoms are there, hence it is called the trihalogen, and here four halogen atoms are there, so it is called as tetrahalogen derivative. So based on the number of halogen atoms present in a particular alkane or a particular molecule, these haloalkanes are classified into these many types: monohalogen, dihalogen, trihalogen and tetrahalogen derivatives. So now let us try to see these molecules one by one. First of all, monohalogen derivatives. So in this monohalogen derivatives, only one halogen atom is present in the alkane molecule. Best example, I'll take only one example because these monohalogen derivatives are again of many types. And in this monohalogen derivatives, these are broadly classified into again two categories based on the hybridization of the carbon to which halogen atom is bonded. So it is of the CX compounds having the sp3 hybridized bond, sp3 hybridized carbon, and the CX carbon in which halogen bearing carbon is with the sp2 hybridization, and with the third one CX carbons in which carbon atom is with the sp hybridization. So these monohalogen derivatives are further classified to three categories: halogen derivatives with the sp3 hybridized carbon, and halogen derivatives with the sp2 carbon where halogen is bonded, and compounds where halogen atom is bonded to the sp hybridized carbon. Now let us take the first category. So in this first category we can write that compounds containing CX bond, compounds containing CX bond where carbon is sp3 hybridized. So in all these compounds the carbon atom is completely sp3 hybridized. And let us take again these are of the three categories, that is primary halogen compounds, secondary halogen compounds and tertiary halogen compounds. In primary halogen compounds, halogen atom is bonded to the primary carbon. For example, ethyl bromide, where this bromine is bonded to the primary carbon atom. And in the secondary halogen compounds, where halogen atom is bonded to the secondary carbon. This is secondary carbon, where carbon is connected to the two other carbon atoms. And in the tertiary halogen compounds, the halogen atom is bonded to the tertiary carbon atom. This is the tertiary carbon atom, where this carbon is again bonded to the three other carbon atoms. And apart from this, one more category is there that looks like an unsaturated compound, but still it is having the sp3 hybridized carbon atom. You just see those are allylic compounds. So, in allylic compounds, the halogen atom is bonded to the sp3 hybridized carbon. You just see allylic means CH2 double bond CH single bond C. Means if any double bonded carbon atom is connected to a sp3 hybridized carbon, that is called the allylic carbon. This is the carbon which is called as allylic. And here double bonded carbon atom is there. So, double bonded carbon atom is there, to which sp3 hybridized carbon atom is bonded. This is called as the allylic carbon. So, based on the type of allylic carbon, these compounds again of three types. They are primary allylic, secondary allylic, tertiary allylic. So, let us take the primary allylic compound CH2 double bond, CH single bond, CH2 Br. So, here this is the allylic carbon which is connected to the only one carbon atom, hence it is called the primary allylic. Secondary allylic means now this is sp3 hybridized carbon and at the same time allylic carbon connected to the two other carbon atoms, hence it is called the secondary allylic halide. And tertiary allylic halides means the compound will be like this. So, this is the tertiary allylic compound. So, primary allylic, secondary allylic and tertiary allylic. Apart from this acyclic compounds, even cyclic compounds also exist like this. This is secondary allylic. This is the primary allylic. Why? Because this is an allylic carbon which is connected to the double bonded carbon. This is a non-aromatic compound. So, that is what is called the allylic and primary allylic. This is the secondary allylic. And let us take the tertiary allylic. This is an example for the tertiary allylic halides. And apart from these primary allylic compounds, even benzylic compounds also will have the sp3 hybridized carbon. Let us see the benzylic compounds. So, in benzylic compounds, we must see the first of all the functional group. What type of functional group is present here? So, here just see, we will take a benzene ring to which a side chain is present. The carbon directly connected to the benzene ring is called as the benzylic carbon. So, this benzylic carbon may be primary, secondary and tertiary based on the number of carbons attached to this particular carbon. So, again these are classified into primary, secondary, tertiary. Let us see them also now. This is primary benzylic carbon because this carbon is connected to the only one side chain, one ring or one other carbon atom. And in this case, This is the carbon which is connected to the two other carbon atoms, hence it is called as secondary benzylic. Now this is called the tertiary benzylic. Why? Because it is again connected to the three other carbon atoms. And in this particular case, these benzylic carbons, secondary and tertiary, they have their own names. Let us see their names also. This is normally called as the benzyl, benzylic bromide or directly benzylic halide. But if one secondary benzylic compounds are called the benzol compounds. Now from here you can write the benzol halide like that. And here it is called the benzo-tri. Means if three same groups are, that is called the benzo-trihalide. If two halogen atoms are present, here it is called the benzol halide, not the secondary one. Benzol, benzo comes when same groups are present. I will take one example here. You just take this molecule. So this is the benzol halide or benzol bromide when two same halogen atoms are present. When three similar groups are present to the benzylic carbon, it is called the benzo. When benzo comes, means automatically three halogen or three derivatives are same derivatives are present. So now we just discussed the type of halogen derivatives. So in this type of halogen derivatives, only monohalogen derivatives, that sp3 hybridized derivatives are discussed. So sp3 derivatives are of how many types? CX bond, whereas carbon atom is sp3 hybridized carbon. So primary, secondary, tertiary normal compounds. And from allylic again we got the three compounds, primary, secondary and tertiary. And from the benzylic compounds also we got the primary, secondary and tertiary. Now our duty is to go for the next part, that is halogen derivatives, where halogen means halogen bearing carbon atom is with the sp2 hybridized carbon. These are all just basics. So CX bond where carbon atom is sp2 hybridized. So once sp2 hybridized means it may be cyclic or acyclic, whatever it may be. So if halogen atom is directly connected to the, if halogen is directly bonded to the sp2 hybridized carbon, sp2 hybridized non-aromatic compound, they are called vinyl compounds or simply vinyl halides. You must remember that the compound must be non-aromatic, okay, because in aromatic also sp2 hybridized carbon may be present. So now let us take some of the examples here. So in that examples, you just take the CH2 double bond CH Br. This is the vinyl bromide, where halogen atom is directly bonded to the this particular double bonded carbon atom. So these are called the vinyl halides. And these vinyl halides again you can see like this also, we can write even cyclic molecules also. This is also a type of vinyl halide, cyclic compound, okay. And you should not connect this sp2 now halogen to the sp2 hybridized carbon. What happens if you connect the halogen atom to the sp2 hybridized carbon? They are called the haloarenes. That we shall discuss at the end of this today's session. So this is about the sp2 hybridized carbon atom molecules. And what about the, if CX bond is present but carbon atom is sp hybridized, then they do not have a separate name. You just take the molecule like this also, or else you can take like this also, bromine, chlorine, any halogen. But once this halogen you are adding means that compound must be, the triple bonded carbon must be at the end position. So it's a terminal one. You cannot add the halogen to the internal triple bonded carbon atoms, internal alkanes. Why? Because the carbon atom valence is already completed. Now let us see the other category. Only monohalogen derivatives so far we have discussed. Monohalogen derivatives. So let us discuss the dihalogen derivatives. So dihalogen derivatives means the compounds where the halogen compounds where two halogen atoms are present, called as the dihalogen derivatives. This you know already, just revising the basics part. Because dihalogen derivatives, one name is important for us. For that purpose only I am discussing the entire classification. So in this dihalogen derivatives, so these dihalogen derivatives may be present on the same carbon atom. They may be present on the same carbon atom, or they may be present in the different carbon atom. So this different carbon atom means the carbon atoms may be on the adjacent side, or they may not be non-adjacent side. So based on this, dihalogen derivatives are of three categories. So if two halogen atoms are present on the same carbon atom, these are called the geminal dihalides. Geminal dihalides, and their name is alkylidene halides. And if the two halogen atoms are present on the adjacent carbon atoms, they are called the vicinal dihalides, or simply vicinal halides, or they have one more name, that is alkyline halides. Non-adjacent side. So in the case of the non-adjacent side, we need to see the position, whether they are respectively adjusted to the alpha, gamma, or alpha, omega, like this. So based on the respective position, we can decide these molecules. But same carbon atom means geminal halides. These are also called as simply gem halides. Vicinal dihalides means simply these are called the vis halides, their shortcut name. Let us see example of these geminal halides and vicinal halides. So here I will take some of the examples. So here just take the CH3, CH, Br and Br. Two halogen atoms are present on the same carbon atom. So it is a example of the gem halide. But here two carbon atoms are there. So you just introduce the name alkyl part here. Two carbon atom means its name is ethyl. So that the name of this molecule is ethylidene bromide. So this ethylidene bromide, ethylene bromide, these are so important for us. And the IUPAC name is 1,1 dibromo ethane. Now let us take the same halogen atoms we can keep on the adjacent carbon atoms also. These are called the vicinal dihalides. So vicinal dihalides, their other name is alkyline halides. So here two carbon atoms are there, so that it is called the ethylene halides. Okay, and the name is IUPAC name is 1,2 dibromo ethane. So this is like geminal dihalides and vicinal dihalides. Now I will give one molecule. You just name this molecule. See, two bromine atoms on the same carbon atom of the cyclic molecule, and two halogens are on the adjacent carbon atom of the cyclohexane molecule. So again you can write down just for classification purpose, this is geminal halide and this is the vicinal halides, as these two halogen atoms are placed on the adjacent carbon atoms. Then what about the non-adjacent carbon atoms? So regarding the non-adjacent carbon atoms, we can see the molecules like this, CH2, Br, CH2, CH2, Br. Then in such cases, the first halogen carbon atom you have to give the name as alpha. So one of the halogen bearing carbon atom to be named as the alpha carbon, this is the beta carbon, this is the gamma carbon. So these are called the alpha gamma dihalides, and it may be like this also, CH2, Br, CH2, 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 Br. So here you can write the alpha, beta, gamma and delta like this. Even you can go for the one more halogen, one more carbon atom. Here bromine, here bromine. So these are to be named as alpha, beta, gamma, delta, omega like this. So these are called the alpha gamma dihalides, alpha delta dihalides, alpha omega dihalides, but only up to gamma we take, and afterwards we just give the 1, 2, 3 names, not these notations. These notations are not of use after the delta. So like this dihalogen derivatives can be classified. Now let us see for the trihalogen derivatives, but here you must remember one particular thing, that regarding the name of the geminal dihalides and name of the vicinal dihalides, E comes for vicinal halides, D comes for the geminal dihalides. So now let us take the another one, trihalogen derivatives. Trihalogen derivatives. Here general trihalogen derivatives are called the haloforms if only single carbon atom is present. Let us take here CHX3. This is the general formula of the haloform. So this X may be any of this halogen, chlorine, bromine, iodine. If you take the bromine, it is called the bromoform. And let us take the Cl3. If you take the chlorine, it is called the chloroform. And if you take the iodine, it is called the iodoform. So when only one carbon atom is present in a trihalogen derivative, then it is called the haloforms, otherwise normal trihalogen derivatives. And tetrahalogen derivatives. So in the case of the tetrahalogen derivatives, these tetrahalogen derivatives will have the 4 halogen atoms. So I will take some examples: CCl4, CH2, I will erase this one, I will take the CHCl2, CHCl2, or else CH2Cl or CHCl3. So like this, 3 and 1. So any of these combinations you can take, but in a molecule, if all the hydrogens are replaced by the halogen and no hydrogens are left behind, such molecules are called the perhalogen derivatives. 1 minute, I'll erase this one. And these are not called the perhalogen derivatives, these are simply tetrahalogen derivatives. Though here 4 halogen atoms are there, name wise we call it the carbon tetrachloride or tetrachloromethane, but it is also called the perhalogen derivative. I will take one more perhalogen derivative. See, let us take this particular ethane combination only, CCl3, CCl3. This is called the perchloroethane. So when we say perchloroethane means all the hydrogens are replaced by the chlorines. Perchloromethane means all the hydrogens of methane are replaced by the chlorine, like this. So whenever you use the perhalo means automatically all the hydrogens are replaced by that respective halogen atom. Otherwise they are simply called the tetrahalogen derivatives. Now coming to the point of the aromatic hydrocarbons means aromatic halogen derivatives means haloarenes. In the case of the haloarenes, a simple thing is halogen atom is directly bonded to the carbon which is sp2 hybridized. Moreover, this carbon is the part of the aromatic ring. Part of the aromatic ring. If it is not the part of the aromatic ring, it shall be called as the vinyl halides. If it is a part of the aromatic ring, then only it is called the haloarenes. I will take some examples for this. You see here, bromobenzene, and let us take these molecules also. So in these molecules, if they ask you which is the vinyl halides and which is the aromatic halides, means this is the aromatic halide, so that this is the haloarene. Why? Because here halogen is bonded to the sp2 carbon atom which is a part of the aromatic ring. But in this case, no doubt halogen is connected to the again sp2 carbon atom, but which is not the part of the halogen, means that means aromatic ring. And here also this halogen is connected to the sp2 carbon atom, but the ring is not the, means the compound is not the aromatic compound. So here this is the carbon which is not the part of the aromatic ring. You may ask the question, what about this particular molecule? Whether we call this molecule as the haloarene or not. No, we should not call this one as the haloarene. This is simply vinyl halides. Vinyl halide in the sense one of these hydrogen is replaced by the benzene, but not the bromine atom is not directly connected to the aromatic ring. So haloarenes in this sense, the compounds in which halogen atom is directly bonded to the carbon sp2 carbon which is a part of the aromatic ring, then only it is called the haloarenes, otherwise they will not be called the haloarenes. So you must be very careful in selecting whether which compound is haloarene, which compound is not the haloarene. These are all vinyl halides, not the haloarene compounds. So now let us see how to prepare some aromatic compounds, means halogen derivatives. Isomerism we have discussed separately, so that I am not covering in this particular part. It was separately discussed in the reaction mechanism. You can refer that notes. So methods of preparation of halides. Methods of preparation of halides. Halides in the sense not the inorganic halides, it is the haloarenes or haloalkanes. So these haloalkanes can be prepared from means these halogen compounds, organic halogen compounds can be prepared from 3 to 4 different type of the compounds. That is, first one is alkanes. From alkanes, you must remember one thing here. Alkane, when subjected with the halogen compound, means halogen, it produces the alkyl halide. So here halogenation, how the halogenation takes place? Halogenating reagent we have to use it. So whenever alkane is subjected with the halogenating reagent, we get the haloalkane. So let us try to see the halogenating reagents here. These halogenating reagents are halogen means I'll take halogen directly. If you made this halogen with the means alkane with the halogen, you will get the haloalkanes. So this halogen may be F2, Cl2, Br2 or I2. And if you are using the F2, no other conditions are required. If you are using the chlorine, you need the help of the sunlight. If you are using the bromine, you need the help of the catalyst or heat. When you are using the iodine, you need the help of the oxidizing agent like HiO3 or HNO3. These are the one part. The other halogenating agent is SO2Cl2, sulfuryl chloride, in the presence of the sunlight or peroxide. So this reagent you must remember in order to convert a particular saturated hydrocarbon to the haloalkanes. And in these cases, we should not use the fluorine reaction directly, as it is too violent to be controlled. And generally we do not prefer even iodination also, which is too slow to complete the reaction. So usually we prefer this chlorination and bromination and even SO2Cl2 also. So let us take the molecules here. You just take the methane molecule subject with the chlorine in the presence of the sunlight, we will get the methyl chloride. When you take ethane subject with the bromine, you will get the ethyl bromide. But the condition is whether you are taking bromination or chlorination, if the hydrocarbon, whatever the hydrocarbon or alkane you are selecting is having only one type of the hydrogens, then you will get only one type of the alkyl halide. And if you want to get only monohalogen derivative, in such cases, always try to take the alkane molecule in excess amount and halogen in the less amount. I'll take you one more example here. For example, if you take the methane in excess plus chlorine in limited quantity, use the sunlight, so that definitely you will get the methyl chloride. But if you take the methane as the limited amount and chlorine in excess and use the same condition sunlight, you may get the different type of the molecule. So that methyl chloride is possible, or else CH2Cl2 dichloromethane is possible, or else CHCl3 chloroform is possible, or else CCl4. Not all possible. Any of these molecules can be possible based on the number of moles of CH4 you are taking. If you are taking 4 moles, maybe 4 are possible, or else any one compound may be formed in an excessive manner. So that in order to get the haloalkanes from the alkanes using the halogenation method, you always take the organic compound hydrocarbon in the excess and halogen in the limited quantity, so that we shall get the haloalkanes in a required manner. And second thing is, what happens if more than one type of the halogen means hydrogens are present, like this sunlight? So that here two different type of hydrogens are there, primary hydrogen and secondary hydrogen. So that's why you will get the two compounds CH3, CHCl, CH3 plus CH3, CH2, CH2Cl. This is the primary compound and this is the secondary alkyl halide, and the major compound is secondary alkyl halide, and we have already calculated the percentage of the formation and how much percentage of this type of the chlorination and bromination compounds are formed in our previous videos. You can search for that video. Okay, So that I am not covering here. If different type of the halogen hydrogens are there, so different number of the alkyl halides will be formed. So number of alkyl halides we are going to get depends on the number of type of the hydrogen atoms present here. Next, how to get the one more molecule is there. Now you just take the halogen cyclohexane molecule. This cyclohexane molecule is subject with the SO2 Cl2 in the presence of the sunlight. You will get the chlorine. Okay, because chlorination takes place on the alkanes. The thing to be remembered here is these reagents. Any of these reagents on reaction with the alkane gives the haloalkanes. So others are simply application methods. Examples. Now let us see the how to prepare the haloalkanes from alkenes. From alkenes means alkenes, the molecules may have the two types of the carbon atoms. Alright, these alkanes may have double bonded carbon, that is sp2 hybridized carbon, and only single bonded carbon, that is sp3 hybridized carbon. So if you want to make this double bonded carbon into alkyl halide, then we have to use the HBr or HCl as the reagent to convert them into the alkyl halides. But if any sp3 hybridized carbon atom is present and this sp3 hybridized carbon atom is bonded to the double bonded carbon, means this is allylic carbon. So if allylic carbon atom is present, then always use the NBS, N-bromosuccinamide, as the reagent to convert the sp3 hybridized carbon atom into the halogen substituted compound. So here use the HNu and H2O2 peroxide. So these are the main things to be remembered for this particular method. So remaining are just examples what we are going to cover over here. You take CH2 double bond CH2 plus HBr gives CH3 CH2Br, and you take the CH3 CH double bond CH2 plus HBr, then you will get the CH3 CHBr and CH3. Now you take the CH3 CH double bond CH2 plus HBr in the presence of the peroxide, that means H2O2 I will take here. So the molecule is CH3 CH2 CH2Br. This is Markovnikov's rule. This is anti-Markovnikov's rule. That rule had been discussed in the previous videos. You can search for those videos in our playlists. You can get it. And this was clearly discussed. And next one is, so in these particular cases, if you observe, my intention to discuss this particular part is HBr is completely attacking over the double bond part of the molecule. See, though here sp3 hybridized carbon atom is there, but it is completely unaffected. Only this part is affected by the HBr in all these three molecules, because we are using HBr or HCl. You can use the HCl also, but if you use NBS, then the product is different. So I will take the same molecule here again, just see CH3 CH double bond CH2 and use the N-bromosuccinamide in the presence of the HNu or peroxide. Now this N-bromosuccinamide preferably will introduce the halogen atom on this sp3 carbon atom, so that we will get the CH2Br CH double bond CH2. But the same molecule if subject with the HBr, we get this molecule. The same molecule if we subject with the HBr in the presence of the peroxide, we get this molecule. Okay, so you must be very careful in selecting the reagent in order to get the required product. Whatever the product you want, so based on that you have to take the reagent. So reagents are so much important. Remaining are just only example reactions. Example reactions we can write anything, but in these important reactions are only how we are going to convert them into the required product. Now, from alcohols. So, how to convert the alcohol? Alcohol means we know that ROH part to be converted to the RX part using some again halogenating agent. So, this halogenating agent must be able to replace this OH part and able to introduce the halogen atom at the same carbon atom. So, what is this halogenating agent? So, these halogenating agents are of different category. They are, you can take concentrated HCl with anhydrous ZnCl2. Second one is SOCl2 ether. Third one is, it may be PCl5 or PCl3. You can take the PBr5 or PBr3. That means if you want the bromine, you take the bromine combination, PBr5 or PBr3. So that I am not writing them as a separate reagents. So you can take even Pi3 also if you want the iodine combination. So basically these all combinations are with phosphorus with halogen, that you must remember. So phosphorus with chlorine means these two combinations, phosphorus with bromine means these two combinations, phosphorus with iodine means this combination. So these are the reagents that helps us to in order to convert the alcohol to the halogen. So I will write down those reactions also here. ROH I will take, just only for example purpose I am writing concentrated HCl, anhydrous ZnCl2 and heat it. So we get the RCl, and this reagent is called as the Lucas reagent. But the name of this reaction is Groves reaction. Name is different, reagent is different, and this reaction is helpful in the identification of the type of the alcohols, primary, secondary and tertiary. And next, if you take the SOCl2 ether, you will get the RCl, and if you take the PCl5 or PCl3, you will get the RCl. If you take the PBr5 generally do not exist as it is unstable, so PBr3 will get the RBr. If you want the phosphorus iodine combination Pi3 or take the P plus I2, so you will get the alkyl iodides. And in these reactions, the purest method that is helpful in the preparation of the alkyl halides is using the SO2Cl2. The reaction is called the Dargins reaction. Okay. Now let us see other reaction. One more reaction, Hunsdiecker reaction. In this Hunsdiecker reaction, we convert the silver salts of carboxylic acid. You just take the silver salt of carboxylic acid. It is a very interesting thing, so because the products are different here. If you subject with the bromine in the presence of the CCl4, you will get the alkyl bromides based on the type of carboxylic acid you take. So just I will take some examples here, then you will come to know. See, RCOOAg, silver salt of carboxylic acid, is subject with the bromine CCl4. You will get the RBr. Okay, and this silver salt of carboxylic acid must be either a primary or a secondary type of the alkyl group must be present in this particular area. If you take the tertiary, then it gives the alkene with the same reagent. Okay, and instead of the bromine, if you use iodine combination, iodine CCl4, then the product is ester. So for each and every one, I will write one example, but you just remember this particular part which is helpful. primary secondary alkyl group if present, that shall give the alkyl halide. If you take the tertiary silver salt of carboxylic acid, then you will get the alkene molecule, and if you take the iodine in the presence of the CCl4, you will get the ester, not any of the alkyl iodide. So I will write down this one. And this mechanism follows a free radical mechanism, hence no rearrangement. So I will take a general example. CH3COOH, directly carboxylic acid I am taking. So you take this silver nitrate. Silver nitrate react with the carboxylic acid and giving the CH3COOH, silver salt of the carboxylic acid. Later let us subject with the bromine in the presence of the CCl4. We get the CH3Br, means the CO2 will be removed and one of this bromine and silver will go as a silver bromide. So whenever in the coming reactions, if I use the carboxylic acid, I use these two combinations at a time. If I take this one, only this will be used. So the more examples are, let us take the CH3, CH2, COOH I am taking. Now Br2 CCl4, so that you will get the CH3, CH2, Br. This entire part will be removed. Now I am taking CH3, CH, CH3, COOH, carboxylic acid. So what are the things required here? Silver nitrate, because initially this carboxylic acid is to be converted to the silver salt and later subject it with the bromine in the presence of the CCl4. So this entire part will be removed and later we get the molecule like this. Okay. Now what happens if a tertiary alkyl halide is taken? So in the case of the tertiary alkyl group is present, it gives alkene, not alkyl halide. COOH, use bromine CCl4. So you will get the CH2 double bond C, CH3, CH3. This part will be removed and here hydrogen also will be removed and here double bond will be created, so that we get the alkene molecule. So you must be very careful in selecting the reagents. Then what happens if halogen is changed? See here, we shall take the 2RCOOH, carboxylic acid molecules in the presence of the AgNO3. Now take the iodine and heat it. Then you will get the R, C double bond OR. So it becomes the ester, carbon dioxide, later silver iodide. So the formation of the esters from silver salt of the carboxylic acids using the iodine, this particular reaction separately called as Simonini reaction. So I will give some homework, just note down that homework and solve these questions, and you must be careful about this one. So whatever the reaction I am discussing from haloalkanes onwards, I will explain like this only. So summary of the reaction will come first. So later it will become very easy for you to solve the questions. So I will give some questions, you please note down that questions. So find the product in these reactions. You just write down only major product. Anyhow, video will be shared. If you are unable to copy, you can see the video, but I am observing that you are not completely watching the videos. Please watch the videos completely till the end, so that you will get the answer for those, means clear explanation you can understand. Hope you understand today's class, and tomorrow's class will be continued.